Morning, everyone.
Morning.
Hello.
Good morning, ma'am.
Good morning. So, we're going to start the session. Good morning to one and all present here. Dear authors and invited guests, welcome to the technical session 13A. Myself, Aarti Mohan, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you all to the 10th International Congress on Information and Communication Technology, ICICT 2025, London, UK. The 10th edition of the conference is being organized in a hybrid mode. The physical event was held on 18th in UK and the virtual event is being held through Zoom from 19th to 21st February 2025. I hope you all would be enjoying this knowledgeable and interactive session through the day. In this session, we have 6 presentations. Each presenters will be given 12 minutes for the presentation and 3 minutes for the question and answer session round. On 10 minutes, I'll raise a gentle reminder. There's another request to all the participants to stay connected with us till the closing remarks. If you have any sort of query or any update, you can write it to me in the chat box. Just before we get started with our session, I would like to introduce you all to these chairs for this session. We have Dr. Nitin. Um, he is an assistant professor, uh, working as an assistant professor in the Department of Computer Engineering of Vishwakarma Institute of Information Technology, Pune. He has published more than 30 research articles in reputed journals. He has also published more than 100 books. His research interests include data science, machine learning, computer networking, and Internet of Things. It's a pleasure to welcome you on board with us, sir. We have the other session chair, Dr. Deepika. She is an assistant professor, working as an assistant professor in Information Technology Department at Army Institute of Technology, Pune. She has completed her PhD in the year 2023. She has total 8 years of teaching experience. She has published 20 plus research papers in various Scopus in text and UGC approved journals and conferences. She has 4 patent publications and 1 patent grant. Currently, she is associated with research work in different domains like image processing, machine learning, data mining, and artificial intelligence. It's my great pleasure to welcome you, ma'am, on board with us.
Thank you so much, ma'am.
Before we get started with our presentations, I would request our session chairs to have a opening remark to all our participants for their presentation. Ma'am, I would request you to deliver an opening remark. Okay, sir, are you there?
Yes, ma'am. You are not audible for some time.
Actually, I was saying, I was saying, could you please deliver an opening remark to all the participants before we start with
Ma'am,
us?
your voice is breaking continuously. You are not audible properly.
Just, um, can you hear me now?
Yes, ma'am.
Sir, could you please mute your mic? Ma'am, am I audible?
Yes, ma'am, you are audible.
Yeah, okay. So could you please provide an opening remark before we get started with our session?
Yes. So wish you all the best, all the participants, and we can start the session now.
Okay, thank you. Moving to our first presentation, we have applying system dynamics to address planning and monitoring issues. Dear presenter, could you please start with your presentation? I repeat, applying system dynamics to address planning and monitoring issues. Dear presenter, could you please start with your presentation? Okay, moving on to our next presentation, we have collaborative product innovation model with large language models and agentic systems. Dear presenter, could you please start with your presentation?
Okay, good day, everyone. I'm Joseph Benjamin Ilagan. With me is the primary author, Zachary Alabastro. We're from Ateneo de Manila University in the Philippines. So our presentation is a collaborative product innovation model with large language models and agentic systems. Next slide. Next slide. Okay. Gathering customer feedback is an essential yet resource-intensive step in product development and entrepreneurship. Traditional research methods require significant time and effort, making them impractical for rapid iteration. Our study explores an alternative, leveraging AI as a co-pilot to simulate synthetic customer feedback through agentic systems. Specifically, we examined how large language models exhibit so-called homo silicus, the innate ability to demonstrate human economic behavior due to the way LLMs have been trained on vast corpora of text. This capability enables AI to generate qualitative insights in various business contexts, potentially streamlining the early stages of product evaluation. A key aspect of our research was validating whether these AI-generated insights align with real customer feedback. To do this, we applied cosine similarity testing to quantify how closely two sets of data resemble each other. The analysis compared AI-generated responses with actual customer feedback to assess how well LLMs can simulate human-like insights. Findings suggest that LLMs can generate qualitative insights that, in some cases, closely resemble real customer feedback. This approach has the potential to reduce resources needed for early-stage product evaluation, making innovation cycles more efficient. With me today is the first author of the paper, Zachary Alabastro. He will walk us through the research in detail.
Good morning, everyone. So we structured our objectives around these three questions, focusing on the methodology of prompting and the quality of the simulation, along with some considerations for proper implementation. So the research questions are as follows. What general approach for prompting ChatGPT 4.0 to simulate customer feedback? Second, how well can ChatGPT 4.0 simulate economic scenarios using context and psychological intuition? And the third, what considerations are important when simulating synthetic feedback? Before delivering a product to the market, the entrepreneur must face a crucial element in business, product pricing. This is a psychological factor that determines how they perceive product value given many factors, including quality. This allows them to decide if something is worth purchasing more than another similar product in the market. Product innovation and innovation management focus on three driving factors: the competition or environment, current market demand, and advancements in technology. To protect market position or increase presence, the business must be able to distinguish which decisions may result in the most optimal results. Price sensitivity allows businesses to determine customer willingness to pay and perception of value. However, early validation and product feedback can be difficult to achieve in a short amount of time, or it can be costly. So, how do entrepreneurs solve this problem rather, before product launch and commercialization? A notable example is the use of LLMs and agentic systems. By using LLMs and their Homo silicus attributes, users can prompt them to explore economic simulations given certain customer characteristics and business or product descriptions. By using agentic systems, the LLM is given the autonomy to make their own decisions and produce nuanced feedback on stimuli. This employs strategic thinking and layers of selection processes before the final output is given, as long as the prompting technique is properly pipelined. Past work showed that using product feedback and evaluation can help with incremental and time efficient product enhancements for competitive advantage, which are what entrepreneurs need. ChatGPT's models have also shown to generate demand curves and customer willingness to pay. However, on the more quantitative aspect, not much has been said about psychological factors affecting the agent's decision making processes. Chain of thought prompting techniques and few shot inference prompting have also helped with identifying the context and task environment, resulting in lesser hallucinations when producing output. It involves memory, determining customer attributes, and observing human interactions with each other and or the product or service. Overall, this promotes the possibility of task efficiency by leveraging AI with copilot mechanisms. Our methodology centered on using ChatGPT 4.0 with carefully designed prompting frameworks. We generated 70 diverse personas with interdependent attributes to increase the diversity of such feedback. Few-shot prompting was employed to improve response quality by allowing the LLM to understand how customers usually provide feedback. These sample responses were not related to the skincare industry to ensure that there's no bias. The temperature setting of 1 helped balance the randomness and creativity. Through simulation role-playing, the user served as the interviewer, while the chatbot was the customer. The context environment was then introduced, providing 3 businesses, 2 businesses, 2 real businesses, and 1 hypothetical. This was very important for customer competitor perception, such as competitor's product value being better or worse than the other. After gathering simulation responses, the feedback provided to the hypothetical business was then evaluated against real-world customer feedback on a similar business and product. This was performed for 3 trials. The results or output focused on the prices of the 3 businesses and their products, though also including other information such as the product description, ingredients used, properties, and usage instructions. Generally, the qualitative results showed nuanced feedback: positive, neutral, and negative. Cosine similarity results showed an average of 60.55% similarity between the synthetic and real product feedback. This is a sample documentation of the raw feedback given by ChatGPT 4.0. This is a sample picture of how the synthetic feedback looks like compared to real human feedback. Cosine similarity was used for text analysis and comparison. It converts words into vector embeddings and uses computations to analyze the angle between the vectors, or the text heads towards the same meaning. It can range from -1 to 1, with 1 pointing at the same direction or high similarity, and -1 pointing at opposite directions, which means highly dissimilar. Key findings highlight the importance of specific prompt engineering. This allows the LLM to understand the task environment through steps giving it enough time to think. The environment must also be realistic. Attributes must be concrete. For example, age, school, occupation, location, etc., to simulate the market scenario. Few-shot inferencing is also useful in simulating the qualitative data, which were the feedbacks, and how the synthetic customers perceive the value of the product. It may also help with decision-making, tone, and feedback. This can be utilized to generate insights on potential reactions to perceived product value, which is useful for innovation. Although the average score is still below the desired threshold of 65%, this holds promise. Further prompting iterations can help the pipeline improve accuracy and time for product enhancements. Now, when simulating qualitative customer feedback for product innovation, the agents must also be clear and realistic. This means that attribute dependencies must be ensured. The business models should also be concrete and not arbitrary. In the study, the skincare products included the name of the product, which was moisturizing cream, its price point and quantity in peso to milliliters, its benefits, the ingredients used, and instructions for proper usage. These are beneficial in allowing the LLM to reflect on what matches their attributes, hence creating value perception. While this is a good start for synthetic qualitative feedback, human intervention is still necessary, as it is only a copilot. This does not propose human replacements. As for future work, other LLMs can be tested on, such as Anthropic Claude and ChatGPT o1 for logical interpretation and natural language processing. Other purchase levers may also be included. For instance, does FDA approval change value perception? It may also look into marketing and communication strategies. Other industries may also be explored, including medicine, glassware, cookware, among many others. Precision and recall, another statistical similarity test, may also be used in future iterations. To conclude, while our research shows promising results for using LLMs in product innovation through synthetic feedback, it's important to note that this is a co-pilot model, not a replacement for human insight. The potential for efficiency gains is significant. This allows entrepreneurs to exert more effort on preliminary strategic decision-making before further product validation. But implementation must be balanced with appropriate human oversight to produce the most impact. We would like to acknowledge the following for their contributions to the paper. And here are our sources used for the paper.
Dr. Nitin Sakre, session chair. I have a question. Can you just little bit more brief about cosine similarity measure, how it has been used in your case?
Hello, sorry, can you please repeat again?
Yeah, how cosine similarity measure is useful in your research? How you have used it?
Okay, thank you for the question. As we also mentioned in the slide, basically what cosine similarity tries to do is to turn these qualitative feedback into vector embeddings. And so they're more into numbers. And this allows the statistical analysis tool to determine if after some computations, their overall angle connects or directs to the same area, or if it goes to the opposite. So for example, if you have a certain data set between synthetic feedback and real feedback, like what we did in the study, those feedback were turned into vector embeddings or numbers. And basically, after some statistical computation, it checked if they would lead to the same trajectory or angle. And if it did, then that would indicate that the qualitative feedback, when it's turned back to actual words, if it would really direct or if it would have the similar or same meaning. So when we did research on the thresholds and the specific let's say numbers or measurements to determine if it's similar or not, -1 shows that the angles of both the synthetic and the real customer feedback were facing opposite sides. And that means that in the qualitative feedback, they're actually very different or opposite to each other. Let's say this customer says that the product is useful or beneficial to them, while in the synthetic feedback, the customer says that it's not. So that's what the numbers represent. And that's what cosine similarity tries to do.
Thank you. Satisfied with your answer.
Okay, one question from my side. Am I audible?
Yes, ma'am, you're audible.
Okay. So the question is that how you are going to ensure that these AI systems, whatever you are using, are designed to be transparent or say unbiased and accountable, particularly if you consider the diverse global market.
Sorry, can you please repeat the question again? I was
How you are going
lagging.
to ensure that whatever the AI systems you are using right now, they are designed to be transparent or say accountable, unbiased, if you consider the diverse global market.
I think it's important to start to ask if there's actual. Sorry, am I heard? Can I be am I clear?
Your voice is breaking.
Please give me a second. How about now?
Continue.
Okay, thank you. So I think it's important to immediately prompt it at the start because it's not something that let's say this model specifically would outright say that this comes from these sources or it's referring to this kind of statistic, this kind of data. So if you want it to be very transparent, obviously you have to be very clear with how you prompt it. I think the golden rule is for prompting specifically is when you're trying to prompt it to an AI, it has to be like you're telling someone who has absolutely no idea of what the context is. And so if you're very clear with your rules and instructions, then the AI will also understand how it needs to deliver data or how it needs to deliver output to be transparent. And so if you're looking into different industries or global markets, then it's ideal that at the start, when you're prompting or configuring the agent to deliver certain qualitative data or qualitative feedback rather, then at the end you have to explicitly state where or how it derived such feedback and what statistics or real data is it using to deliver such output.
Okay, thank you from my side.
Thank you. Thank you so much for your presentation. Moving on to our next presentation. We have enhancing sarcastic language detection by exploring the potential of machine learning and deep learning approaches. Dear presenter, could you please proceed with your presentation? I repeat, enhancing sarcastic language detection by exploring the potential of machine learning and deep learning approaches.
Yes, just a minute to share the slides.
Yes, please.
Okay, good morning, everyone. My name is Dr. Jihan Al-Jaradi. My topic, as you can see here, enhancing sarcastic language detection by exploring the potential of machine learning and deep learning approaches. Let us see this slide. If you look at this slide, it looks like a humorous slide that introduces our topic. Here you can see that we put a aquatic image with an ironic caption. As you see in the image, a house is inside flames, and combined by we can say that an optimistic and positive caption, everything is fine. However, the reality is opposite. This highlights a common psychological response to overwhelming situations and ignoring the problem, even though the crisis sites are very clear. So I think this is just an introductory image to our topic, which is sarcasm, which is an expression where a person uses strongly positive words in their writing to convey negative feelings. Here is the definition of the sarcasm and how it is important. How detecting sarcasm is important. Actually, detecting sarcasm on social media is very essential for refining communication and reducing misunderstanding between the users on social media. Also, when understanding the opinions and views of the users, our communication will be more I think useful and fruitful. So what about the applications of sarcasm detection? Actually, sarcasm detection has many applications in the natural language processing tasks, such as fake news detection, sentiment analysis, opinion trolling, dialogue systems, also machine translations, and more others. So its importance and I think critical applications in natural language processing tasks, detecting sarcasm is not an easy work, and it is a challenging task because it depends on the context, on the tone, and on the cultural variability of the writer or speaker. So we cannot understand what the speaker or the writer means. Even we know the context in which he put his words and voice. For example, the tone of the speaker can tell us what is the intention behind this speaker. Either it is positive or negative. Either it is for satire or for humor. Also, subjectivity is another crucial challenge that face detecting sarcasm. Here is the key contributions of our investigation or exploration. The first one is to compare the performance of traditional and advanced machine learning and deep learning, also transformers models, to know their effectiveness in detecting the sarcasm or sarcastic language on social media. The second contribution is to explore how we can take the advantage of transfer learning in text coding, which can help to improve the performance of deep learnings by using the pre-trained digital paired method. Actually, we apply this method as it can discover the contextual representations and the semantic relations between the words. Also provides a meaningful and valuable embeddings. Furthermore, this approach could reduce the extensive training and computation required during the model training phase. Here is the methodology. We will start with experimental setup, study framework, dataset, data pre-processing, including word embeddings and feature extraction. Then we come to the model architecture. For experiment setup, actually, we implement our models using Google Colab Pro, using the TensorFlow, Keras, and Scikit-learn libraries. For performing and implementing a support vector machine model, we use Scikit-learn library. And for the deep learning models, we integrate TensorFlow and Keras libraries as they show fruitful and robust results. And for measuring the performance, we apply the four famous performance metrics, including patient accuracy, recall, and F score. In this slide, we can see our study framework. We start by data acquisition. In here, we use news headline data set, sarcasm data set. Then we come to the pre-processing, then the refined data set. After that, we split our data. We have here extraction feature extraction methods. Then the classifiers that we have used in our model coming to the output, then the performance evaluation. All these will be discussed in the coming slides. We apply our models using the dataset, which I think it's a benchmark dataset, news headlines, dataset for sarcasm detection. Actually, we use this data because we can say that all the headlines are written by professionals. So this data, it looks fair and fine without any mistakes. But one issue with this data is it is imbalance. There is, we can say that more instances for non-sarcastic examples and less for sarcastic instances. Here we can see it. We have 25, more than 25 non-sarcastic instances and 20 more than 20 for sarcastic instances. And I think this could skew our models. So to ensure a more equal data set, we try to make them in balance. And you can see here in the table below, after adjustment, we have 20,059 for the sarcastic instances. And also here, after adjustment for the non-sarcastic sarcastic instances. Here we come to the data processing, pre-processing. Actually, each model has its own pre-processing method, but all of them can share general data pre-processing. First, we convert the list of the words or dictionaries to pandas data form for smooth implementation. Then we can concatenate the two data sets, the onion and the HuffPost, to simplify our pre-processing. Then we come to the cleaning of the noises and removing stop words, normalizing words, duplicates, and all these pre-processing steps. After that, we come to extracting the features, analyzing different techniques. We have here the feature extraction methods. We have term frequency, inverse the document frequency, word to vec, glove to glove vector, and we have this style hurt and BERT. If we look at this figure, it shows the distributions of the words number for each headline after the pre-processing step is applied. And we can see that each headline has no more than 20 words. feature engineering in support vector machine. Now we will come to more specific explanation of feature engineering for each model. For support vector machines, we use the term frequency inverse decrement frequency vectors and the globe vector globe vectors for word representations, and for better we can say that representations of word embeddings, we concatenate these methods for better implementation and robust results. For here we have text pre-processing for deep learning models. Actually, deep learning models need different method for pre-processing. So for in our study we have two experiments. The first one we use the feature extraction like that used in support vector machine model. And in the second experiment is using the learning transfer learning method, digital paired based encased method. Actually, we use this method because of its handling of the semantic relationships and contextual representations between the words in the headlines.
Dear presenter, you have only 2 minutes for the presentation. Could you please conclude your research?
Okay. So we can say that for paired text pre-processing for paired model is it's different also from the above mentioned models. So we have here the tokenization. We use pair tokenizer to convert the tokens into IDs, including tokenized mask and segment IDs. Then we have adding special tokens, creating attention masks. Let us come to the results. If we look at this table, we can see that the paired model outperforms all the rest of the models used for this exploration with 98%. Then come the by long short-term memory, then recurrent, and the last is support vector machine. However, there is a slight, we can say that bilingual short-term memory is ahead slightly over recurrent neural network because of its both direction strategy. So now here we can see that the difference between the results of the performance of the models when incorporating distal BERT models and without distal BERT models, we can see that there is a significant difference in the performance of the two deep learning models. Here we can say that the accuracy and loss as well the validation accuracy across for the recurrent neural network model. Here we say that also the accuracy for the bidirectional long short-term memory. Here is the results on regarding the accuracy of the BERT model. We can say that it is very high, about 89. Here we have the confusion matrix for the model and deep learning models. We can come here to the conclusion, and we can say that still we have limitations for our study, that we need to incorporate more extraction techniques. Also, we need to incorporate multimodal data for that include text, audio, video, emojis, and etc. Also, we need to apply our investigation on more benchmark dataset for sarcastic detection. Thank you. Questions?
Thank you.
Yes,
Thank you so much for your presentation. Ma'am, any question?
yes, I have one question.
Yes, ma'am.
The question is that whether this sarcasm detection benefit for the multimodal approaches, such as if you take for the language detection, so whether it is going to consider the tone of voice or a user interaction, any online forums or any social media, any kind of multimodal approaches, will it support?
Yes, actually, I think that multimodal data will facilitate sarcasm detection, as we can see that detecting sarcasm from writing is more difficult and challenging than detecting sarcasm from the spoken language. As when a person is speaking, we can see from his facial expressions, from his body language, that whether he means to say something that is positive or negative, humor or satire.
Okay, thank you.
You are most welcome.
Thank you, ma'am. Thank you for your question, sir. You have any questions?
No questions.
Okay. Moving on to our next presentation, we have evaluation of a customer development stimulator using large language model-based multi-agent system and synthetic respondents. Dear presenter, could you please start with your presentation?
Can everyone see my screen?
Yes, your screen is visible.
Okay. So, hi everyone. I am Lois from the Ateneo de Manila University, and I'm here to present our research on building a customer development simulator using a large language model-based multi-agent system and synthetic respondents. So, over 90% of startups fail, not because of poor execution, but because they build products nobody wants. What if we could change that? Customer development, a core principle of the lean startup methodology, focuses on understanding customer needs and validating business hypotheses before launching a product. Rather than starting with the product in mind, the goal is to start from the customer, then work backwards. The customer development process has 4 steps. We will focus on customer discovery, where the iteration happens as founders explore target customers. Studies show that incorporating customer development leads to a lower risk of startup failure and other significant advantages that places startups at a competitive level, such as improved market fit and validated learning, among others. However, traditional customer development relies on resource-intensive activities, such as surveys, focus groups, and interviews, which can be costly, time-consuming, and often subject to participant biases or incomplete data collection. But what if there's a better way to simulate customer behavior, one that scales, adapts, and provides realistic insights? Using large language models, founders can simulate diverse customer sentiments, benefit from its flexible nature, and conduct natural language understanding with zero-shot prompting. Knowledge from these LLMs can then be used to build a multi-agent system that interacts, performs tasks, and possesses partial real-world perception. It can also boost efficiency and cost, flexibility, and reliability. Combined, we propose leveraging large language model-based multi-agent systems, particularly their capabilities for complex problem-solving and real-world simulation, to support customer development, enabling more efficient hypothesis testing and reducing the time and resources needed for early-stage validation. This study examines the following research questions. We explore how LLMs, multi-agent, and natural language understanding capabilities can be used to enhance the customer development process. We also study what considerations should be employed to obtain valuable feedback for startup validation. A review of related literature showed 3 main points. First, early customer discovery is optimal for lowering costs and increasing chances of success. Second, idea validation is key to developing roadmaps, through market testing. Stakeholder discussions help founders assess market fit, potentially reducing failure. However, this may require considerable resources. Third, LLMs have been tested as simulation tools for customer development, though improvements remain necessary. While initial results are promising, studies recommend presenting real business ideas to synthetic customer personas for better validation. This may increase adaptability to nuanced scenarios and reduce potential biases. Additionally, numerous research and business applications emphasize the importance of multi-agent implementation in enhancing these simulations. Our methodology introduces a mechanism for testing business hypotheses using synthetic agents. We designed an LLM-based multi-agent system that comprises two distinct agents, a founder agent and a customer agent. The system utilizes OpenAI's GPT-4 model with memory retention enabled to ensure consistency in interactions. This approach is grounded in the customer development framework, particularly on the customer discovery phase. Prior to the simulation, a real business idea was input into the system. Customer agents then generated realistic customer attributes and provided feedback based on their personas. Meanwhile, founder agents pose targeted questions to explore customer needs and validate hypotheses. Both agents autonomously facilitated inquiry and generated insights without direct human involvement. The table on the left shows a sample of results from the conversation between the two agents. The results of the proposed simulation model demonstrate consistency, but further evaluation is needed. Outputs from both founder and customer agents were thorough and aligned with human feedback. The responses effectively captured persona-specific contexts and pain points, suggesting that the model can replicate authentic customer interactions. Our study revealed the following. First, when integrated with chain-of-thought prompting, multi-agent systems can effectively generate contextualized feedback that are aligned with customer development objectives. Incorporating natural language understanding and real-world context allows them to closely mimic reality and intelligently select natural responses through advanced reasoning. The model should be second, comprehensiveness and interdependence are crucial for creating an accurate and authentic simulation model. The model should be provided with detailed business context, real assumptions, diverse customer segments, and a clear business model. Customer agent attributes should also reflect real market variations and interdependencies. For example, social behavior should match income level attributes. Finally, chain of thought prompting and conversational memory recall improve reasoning and adaptability, particularly when inter-agent conversations evolve independently. Nonetheless, establishing custom guardrails is crucial to mitigate potential biases and maintain data quality. For future research, we recommend testing the multi-agent simulation with real founders and customers to assess its real-world applicability. Fine-tuning the model can further enhance its robustness, accuracy, and efficiency. Exploring multi-agent system configurations, such as one-to-many agent structures, may provide deeper insights into the model's adaptability across diverse conditions. Further experimentation with latter stages of customer development is also encouraged. Finally, implementing quantifiable and systematic human evaluations are essential to rigorously measure the system's effectiveness. In conclusion, LLM-based multi-agents are a promising complement for customer development with the potential to scale, adapt, and generate realistic insights. However, further testing is needed to confirm its effectiveness in real-world scenarios. For this paper, we would like to acknowledge the following, and thank you very much for listening. The floor is now open for questions. These are also some of the sources that we have for the paper.
Yes, I have one question. That if we apply the large language model that with your multi-agent system, so will it simulate the real customer behavior or will it go for the hypothetical scenarios for large language model?
For large language models, it is best to simulate realistic customer attributes and also data to be able to make sure that we generate results as similar to the real world cases as much as possible.
Okay, and why you selected this LLM or synthetic agents instead of the traditional customer feedback mechanism?
So this one is to analyze the LLM's capability to see whether it's able to generate realistic customer insights so that entrepreneurs and founders would be able to see if this can give them preliminary insights that will then guide them as they do traditional customer development or other related activities.
Okay, thank you from my side.
Thank you, ma'am. Thank you for your question. Sir, you have any questions? We have the paper title Improving Customer Service in Ghana's Banking Industry Utilizing ChatGPT to Better Understand Customer Sentiments. Dear presenter, could you please start with your presentation?
A minute, please. I'm coming.
Do let me know if you can see my screen.
Yeah, started sharing. Okay, I can see your screen now. Thank you very much. So thank you for allowing me to present my paper on improving customer service in the banking industry, utilizing ChatGPT to better understand customer sentiment. And so our presentation focuses on how ChatGPT can address customer service in the banking industry in Ghana. So the study examines how banks can leverage on AI to understand and respond to customer service, customer sentiment in real time. Please can you go to the next slide? Sorry, so this is the outline. The slides provides an overview. This slide provides an overview on the presentation. So first, we will cover the introduction, explaining how the significance of the topic and then the challenge the challenges faced by Ghanaian banks. And next, we move on to the literature review, and then you highlight the previous studies and the role of technology in the banking sector. So the methodology section will discuss the research design and then the data collection methods. We will then review the key findings and before moving on to the discussion and implications. So this study actually focuses on the customer perspective instead of using AI model. So our next study will utilize an AI model on understanding customer sentiments in real time. So in this understanding customer opinions and sentiments are becoming essential for businesses success in today's competitive landscape. So the Ghanaian banks face challenges in adopting advanced technologies to capture and respond to customer sentiment effectively. And so this study aims to explore how ChatGPT can be used to improve real-time service and then real-time customer service and then the sentiment analysis. Next slide. So customer service play a crucial role in the Ghanaian banking industry. So previous studies have identified or highlighted various service quality issues such as inconsistent responsiveness, and insufficient orientation. So advances in digital banking and AI technologies have reshaped customer expectations, and ChatGPT has proven to has proven a usefulness across different sectors, delivering natural and then woman-like responses, and then enhancing customer interaction. So integrating ChatGPT into the banking service in Ghana could transform customer experience by providing efficient and then personalized support, which could lead to customer satisfaction levels and then customer loyalty. Next slide, please. So the study used, like I said earlier, we based on the customer perspective, like the point of view on how that ChatGPT can improve customer service quality and then loyalty. So the methodology focuses on the customer and then there's a representative from the banks. Our next study will focus on utilizing AI model to actually understand customer responses in real time. So the study used a maze method approach. A total of 160 customers from 4 different banks participated in a structured survey to capture their banking behaviors, familiarity with ChatGPT, and then their perception of its potential, ChatGPT's potential use in the banking industry. So additionally, we conducted interviews with 40 representatives, including IT specialists and data analysts, and then customer service managers, to gather in-depth responses in order to understand their view on how ChatGPT can improve customer service quality. So descriptive statistics and then thematic analysis were used to interpret the quantitative and then qualitative data, so providing a comprehensive view on the findings. Next slide, please. So the findings on the banking habits and then the preference. So from the charts, as you can see, respondents' banking behavior shows that the physical branch visits are still prevalent, with 60% visiting the branch monthly and then 20% visiting weekly. So satisfactions with the customer service varied, with many respondents expressing their frustration over slow responses time. So the factors influencing bank choices and then convenience, personalized service, and then reliability. So these findings highlight the need for banks to enhance their physical and then their the digital customer service channels to remain competitive. Next slide, please. So, like from the table, it summarizes the awareness and then usage of ChatGPT. So the survey revealed that 78.1% of the respondents were aware of the ChatGPT technology, which demonstrates a high level of familiarity and then with the technology. However, 60% reported interacting with ChatGPT powered chatbots, indicating a gap between the awareness and then the actual usage. So despite this, satisfaction with ChatGPT were actually high, so averaging 4.2 on a scale of on a 5 point scale. So notably, 85% of the respondents expressed a strong likelihood of using ChatGPT for future in the future. So signaling a growing confidence in AI-driven banking solutions. So this suggests that the banks have a significant opportunity and to adopt and then promote ChatGPT powered services to enhance their customer engagement. Next slide, please. So this is the perception of the ChatGPT's power or ability to improve customer service in the Ghanaian banking industry. So respondents rated ChatGPT's potential to improve customer service with high mean score of 4.5 on a 5-point scale. So many respondents believe that ChatGPT can help banks to improve faster and then more accurate responses to inquiries. So additionally, a mean rating of 4.4, a mean rating of 4.4, and then the importance for banks to utilize the ChatGPT technology, or emphasize the importance of banks to utilizing advanced technologies like ChatGPT for real-time sentiments analysis and the interactions. So expectations for ChatGPT's impacts on improving customer standards were similarly higher, and then which indicates a strong optimism for its integration into the Ghanaian banking service. Next slide, please. So the thematic analysis also revealed that mixed views on the ChatGPT. So we had some representative highlighting that ChatGPT's ability to reduce response time and then provide real-time um, provide them real-time customer support, while others express their concerns about the accuracy and then the handling of sensitive data. So the IT readiness and then the IT readiness and then the staff training also emerged as a critical factor for a successful implementation of ChatGPT technologies into the Ghanaian banking industry. So in all, most participants recognize ChatGPT's potential to, transform customer interactions by delivering more personalized and proactive services. Next slide, please. So the findings suggest that the Ghanaian banks have a significant opportunity to enhance their customer service through ChatGPT. So while the physical branch visits remain common, the growing acceptance of AI-driven technologies points to the shift towards hybrid service model. So positive perceptions of ChatGPT indicates the readiness for its adoption. But however, the banks must address some technological issues in the banking industry, and then human factors such as the IT infrastructure, and then the staff training, and then the data security to ensure the successful transition of utilizing or adopting AI-driven technology to further understand customer sentiment. Next slide, please. So the implication of ChatGPT technology of this research is that so integrating ChatGPT into the Ghanaian banking service can actually foster customer satisfaction by enabling personal and then responsive interactions, and then real-time sentiment analysis will will help the banks to understand and address to customer needs and address customer needs. Next slide, please. So in all, ChatGPT presents a promising opportunity for the Ghanaians bank to elevate their customer service standards in today's competitive landscape by actually leveraging or strategically implementing the AI-driven solutions. So bank can enhance customer experience, foster loyalty, and stay ahead of the digital stay ahead in the digital age. So the study's findings really highlights the readiness for the adoption and then the strong belief in ChatGPT's potential to transform the banking service in Ghana. Thank you very much. This is the end of my presentation.
Yes,
Is any
will you please
question?
answer to one question that
Okay.
how does the ChatGPT will differentiate between positive or a neutral or a, say negative sentiments if it is provided with the text-based conversations?
Okay, so what we wanted to do is just I identified how the potential of implementing it, and then after we delve into like utilizing the AI model to actually analyze the data, the real-time data of customers, and then from the website, from the bank's website, and then from the social media, and then understanding how these sentiments can be analyzed in real time. Please, is your question answered?
Okay, fine. Thank you so much.
Yeah, welcome.
Thank you so much, ma'am. Sir, you have any questions? Yeah, thank you so much for your presentation.
Thank you very much, ma'am.
Moving on to our next presentation, we have the paper title, K Nearest Neighbor Classification Accuracy Approach Using Weighted Distance Metrics and Three-Way Decisions. Dear presenter, could you please start with your presentation?
Right, thank you. Would you stop sharing so that I could continue?
Yeah. Yes.
Are you able to see my screen?
Yes, we can see your screen. Could you please start with your presentation?
Right, thank you very much, panelists and the participants. I'm presenting a paper on hybrid machine learning algorithm for crop yield prediction using incremental learning and k-nearest neighbor. So basically, we approach this particular study by looking at the statement of the problem. And we acknowledge that many researchers have experienced that the combination of various algorithm methods can lead to better prediction results and focusing in the field. And therefore, we note that machine learning ideally has inherent classification deficits, particularly due to high computing power, outliers, and the curse of dimensionality. Therefore, we are trying to create an algorithm that tries to model a new class level using weighted prediction and also uses the k-nearest neighbor. Now, on all this, we note that KNN as an algorithm has various deficits, mostly including the continuation of suffering from the overlapping classes, and even the spectral data. It also has the correlated disjointed data features, And it also has the nonlinear and complex data processes that are affected by the noise in the classification approach. So what makes KNN particularly to be regarded as ineffective in most applications, and we are much aware that the high computational that is involved makes the classification difficult, and even the training of the samples becomes very difficult. So our main objective particularly is to develop a hybrid learning model for crop yield and analyze these machine models, develop a machine model, and evaluate the model that has been developed. In particular, this methodology and the experimental setup looks at the process of the two cubes. And in all these, we derive the variables datasets from well-known Omdina datasets and also the Kango datasets, and we look at the variables of the datasets from rainfall pattern. We look at the photoperiod, we look at the temperature, soil moisture, and soil characteristics. Now, we subject the datasets into the input processing and output level, and we use the library dependency from Panda, and we also use, which we combine with the multiple Python libraries from the Skyline, and we plot this visualization using the matplotlib to visualize our data. And therefore, we evaluate our methods by measuring the accuracy and the F1 score. So in this particular study experiment, we only use the two measure of accuracy. Two evaluation methods, that is the accuracy and the F1 score. Now, we also do our cross-validation so that we can be able to find the unique and the best suit approach in the data that we are using for the KNN algorithm modeling. All right, now, in terms of classifying using the KNN classification distance metrics and a three-way decision design model, we describe our model using this graphical feature by giving the following steps on what we undertake from the data sets to feature selection, feature scaling, the noise and dimensional reduction, to combine a distance metrics, a three-way decision, and then we model a KAN three-way classification model. And interestingly, we use the datasets property. These are the datasets property that we employ directly from the Kango and Omdina datasets. So looking at the analysis of the results, we use the combination of efficient computed Euclidean distance model and adoption of a three-way decision model to boost the classification performance of the KNN. And we use this particularly to achieve better computing power and predictability through the classification in the KNN. Now, we also subject this particular model, and we note that we have a shortcomings of the KNN dependency on the value of K that we are going to choose, since the problem is subjected to the low efficiency and the set of implementation is caused by new data points. Now, we also model this classification to reduce the dependency on K to optimize our classification and make it a little bit faster. So how do we model the KNN? And in this particular testing and experimentation, we subjected the experimental and expression to different modeling and the KNN distance metrics. And we used all the KNN metrics that have already been designed to measure and to model and to determine our best K values using a distance metrics for all the data sets. And then we analyze these data sets range, type, and scale using the distributed data features. And in this consideration, we looked at the interpretability, computational complexity, and how they potentially affect the performance of the KNN algorithms. So you will note that the distance metrics that we use to measure all these included the cosine, the Chebyshev, the Hamann, Euclidean, Manhattan, and Jaccard, and Minkowski distance metrics. So based on all this, we analyzed a data for this particular model, and in coming out with this, we conducted a dimensional reduction, and we used two methods to compare the success rate and unsuccessful rate based on the reduced dimension of instance data and based on the complete dimension of data sets. So you can note from the graphical representation here that we have two models where we measure the success rate and the unsuccessful rate so that we could determine which is the best approach of reduction method that could be used to clean our data sets and use that to model our algorithm. Now, sorry, is the screen moving?
Yes.
All right. Now, we aggregated these particular average results based on the distance metrics for all K values for all the distance metrics. And we conducted these for Hamann, cosine, Jaccard, Manhattan, Euclidean, Chebyshev, Minkowski. And we conducted all these based on the K values that were chosen. The K values ranged from K3, K5, K7, K9 to K13. And we also had a runtime seconds to measure how this was conducted. And in all these K distance metrics measured for each and every distance metric, we conducted an evaluation based on the F1 score and the accuracy average. And these are the results that we got. And these are the graphical representations based on all the dimensions of the distance metrics that were measured. Now, you will note that the average values of these particular distance metrics for the data sets and time were particularly low. And then we subjected this computational comparison, and we measured the time to look at how do the distance metrics based on the K values perform with the time. So this was the noted timelines based on all the distance metrics that were measured. And this graphical presentation measure shows how the distance runtime in seconds measures for all the distance metrics. And based on that, we ordered to try to also look at how does noise affect the KNN distance metrics. And we conducted an experiment based on subjected noise and based on the subjected without noise. And these are the values that were received and the graphical representations that were noted having measured the measurements or the accuracy with noise and the accuracy without noise. Now, interestingly, you will find that there are some distance metrics that performs particularly well based with the noise. And that raises a scientific question. Why do you find that some KNN distance metrics perform better with the noise? Now, if you look at the characteristics of how these distance metrics work, then you'll realize that some work best with nominal data, some work well with the structured data and all that. And the data that we used, the numerical data that we used for the data sets, particularly were not working well with some of the distant metrics. And that is why the experiment revealed that some distant metrics perform better without with the noise. And that was answered and explained in our experimental setup. And this was also subjected to the validation and accuracy score for all the distance metric measures that we found. And we conducted a F1 score based on the precision recall and precision recall for all the K values. And these are the results that were noted. And you find that if you look at the K value for 3, 5, you find that the K values that are lower performs much better than the K values that goes beyond 7, 9, and to 13 and onwards. This was realized based on the value, the noise features that comes in with the added K values in the prediction. Now, when we try to enhance with the KN with our weighted distance metrics, and we introduced weighted metrics for W1, W2, which we set at 0.8 and 0.6, so that we could have a degree of importance between the experiments. So the data that we were using was also based on high dimensional, and this is what we use to split the data in for 80% training and 20% test samples. And these experiments were also subjected to the K values that we have been using from 3 to 13. And using a validation and accuracy score, we use the accuracy score, and we also use the F1 score for the distance metrics for all these values. And we conducted this, and you would be able to see that there's improvement in all the measurements that were carried based on the accuracy scores that have been conducted and evaluation scores that have been conducted. So we injected the weighted average in order to improve the performance of the distance metrics that we were using to enhance accuracy. Now, in the topic, you noted that we used a three-way decision classification to improve our classification. And we also used this particularly to enhance further the performance of the KNN based on the weaknesses that the KNN algorithm already has. So we were trying to solve the inherent problems that the KNN have in the classification. And we used a computational function of three-way decision classification. These are theory-based classification that uses boundary domain, it uses positive domain, and it uses a negative domain. And in mathematical expression, this decision is based on the steps where you are able to analyze a standing feature by looking at whether it is in a neutral position, whether it is on the right hand, which is positive, and whether it is on the left hand, which is negative. And this is expressed by using the thresholds of the mathematical expressions that we have outlined here. So when we conducted these and evaluated these against some of the conventional algorithms
Dear
and
presenter,
classifications.
sorry to interrupt.
All right.
Yeah, could you please conclude your research?
All right. When we conducted all these classifications for all and compared it with accuracy of all other existing algorithms, we noted that our algorithm that we had subjected to the hybrid KN-based three decision dimensions performed well, and we noted that the K value 5 with the hybrid KNN performed much better than all these other algorithms. And these are just the graphical representation of the results. Now, in all these, we note that the results received are subjected to a reduction. And we note that the values that are received are best performed when K value is equals to 5. So we found that the K value tolerate much noise level to a certain degree and are able to produce better results. And we also noted that the KNN can be enhanced using Euclidean distance, which can be able to do noise filtering and produce better results when subjected to a three-way decision. So this research contributes to modeling of a KNN accuracy and prediction using a three-way decision to make efficient and achieve better computing power and predictability. So that is the conclusion of our research, and noted some of the findings that we contribute to in terms of this study. So thank you very much.
Thank you. Thank you so much for your presentation. Ma'am, you have any questions?
Yeah, I just want to know, do you face any challenge like overfitting while implementing this weighted distance matrix in Canon?
Yes, absolutely. The overfitting is achieved because the various data that we use particularly when using large amounts of data sets from various levels, because we're using large data sets of different matrices from the already existing portals for data sets. So depending on the value or the amount of data sets that you take in for this kind of experiment, then you'll realize that overfittings really affects the overall outcome of the results.
Okay, thank you so much.
Thank you. Thank you so much, ma'am. Sir, you have any questions? Okay, thank you so much for your presentation.
Thank you very much.
So that brings us to the end of our presentations. I would request our respected session chairs to share their insights and feedback with our presenters who presented their research in the session. I would request Dr. Deepika ma'am and Nitin sir to share their insights.
Yes, good evening. Here is the evening, that's why good evening. And we today just heard about and something insightful or engaging presentation on different topics from the different authors. So we can say the research has the great potential for both academia as well as the practical applications if we consider the field of information and communication technology very well. So congratulations to all the presenters for their well prepared and very good explanation regarding the topic. Thank you so much.
Thank you, ma'am. Thank you so much for your valuable feedback. Sir, I would request you to share your insights and feedback as well. I would request Nitin sir to share his insights and feedback with our presenters. Okay. So I sincerely thank all our authors and for their excellent presentations and contributions in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on the behalf of the whole team, thank you for the support during this 10th version and all the previous 9 versions of the conference. We would be really happy to have you in the 11th version as well in 2026. All the presenters would be getting their digital certificates within through email within 2 working days. Further, all the papers have already been forwarded to Springer. The publication would be live within 6 months. Kindly please cooperate with the team of ICICT 2025. I would like to thank our respected session chairs for chairing the session, Professor Nitin and Professor Deepika ma'am, for chairing the session and sharing their valuable feedback. Thank you so much, ma'am and sir, for making your valuable presence. A token of appreciation to our respected chairs on behalf of Team ICICT 2025 and Global Knowledge Research Foundation and partners. Thank you. Thank you so much, ma'am and sir, for making your valuable presence. Now, I would kindly request all our participants to please switch on your cameras so that we can have a quick snapshot of the virtual conference. Can I have all the participants to switch on your camera so that we can have a quick snapshot of the virtual conference. Thank you. Thank you so much, everyone. Stay safe and take care.